Hi everyone, and welcome to part 2 of Unit 1, Chapter 1, Lesson 1. We split this in half so that we can go over the CER method of responding to scientific questions so that we can continue with our investigations about Mars and other topics that we'll see later in the year. So when we left, we were looking for whether or not other rocky planets were once habitable. And we were looking for how can we search for evidence. And when we introduced the rocky planets, we looked at ways that we could compare them to Earth. Each of you were given part of the systems, the sphere systems. Each of you were given either atmosphere, hydrosphere, geosphere, or biosphere. Now, we were looking at these because we know this is what we need to keep life here on Earth going, so we're looking for these things on other planets. So today, you're going to talk to your group, and each of you are going to be an expert in your system and try to decide which of these is most like Earth. We're also going to introduce a video that might give you some hints about which planet might have had life on it or could have sustained life if it continued the way it was going. We're looking for evidence or facts so that we can use them to explain which planet we believe is or was the most habitable.
My name is Dr. Lauren Edgar, and I'm a planetary geologist here at the U.S. Geological Survey in Flagstaff, Arizona. One of the key questions driving planetary exploration is, are we alone in the universe? To help answer that question, I'm looking for habitable worlds in our solar system, meaning environments that may once have had the conditions necessary to support life. Two of the main conditions needed for life are a source of energy and liquid water. Liquid water is really important because all life as we know it requires it. So it's the first thing to look for in the search for life beyond Earth. For over 100 years, scientists have been wondering whether Mars ever could have had liquid water. And as we've collected more and more data from Mars, we've realized that Mars is actually one of the most Earth-like planets. But it looks like there's some nice flat blocks in a few places, here. As a planetary geologist, I study rocks on Earth to understand the geology of other planets like Mars. My specialty is actually to look at rocks on Earth that have interacted with water, and then I use that knowledge from Earth to look for similar environments on Mars to figure out whether Mars may have once had flowing water. I'm here in Sedona, Arizona, about 30 miles south of Flagstaff. This area actually looks a lot like Mars and has some similar types of rocks and landforms. So because of this, it's a great place for me to collect samples and make observations that I can then compare to the geology of Mars. Down below me is a river, and it's a great example of water interacting with rock. As the water rushes over the rock, it picks up little individual sand grains and pieces of the rock that get transported downstream and eventually deposited elsewhere. Over time, these water-rock interactions will carve out a landform that I can observe, and it will tell me what to look for on Mars. If water's been carving rock for a very long time, it's possible to make a landform called a canyon. Canyons are deep and narrow landforms with steep walls that often have a river at the bottom. This is a great example of a canyon that's been carved by this river. As a planetary geologist, my job is to gather evidence at canyons like this and compare that to what I can observe on Mars. If I can find similar textures or patterns in the canyons on Mars, then that becomes strong evidence that water once flowed on Mars.
Right. Now, after that video, we have some things we could talk about when we talk about habitability. And according to Dr. Edgar, the two things that we need to have a habitable planet is a source of energy and water. Water, because we know that all things on Earth that are alive require water. And energy, because we need something to keep everything moving. Now, that's kind of why we focus more on the inner planets, because they are closer to the sun and they have more of a direct they get more sunlight and more energy from the sun than maybe possibly the other outer planets. Now, we're looking at ways that we know that something is habitable. If we look at how Dr. Edgar is going about this, she is looking for things on Earth that were once habitable, like places like the Grand Canyon or other canyons in the United States and other places that once had life but no longer had life. And we look at these things because we look for how does the ground change when life was there. So if we look at canyons, you'll notice that it goes deep into the middle because rivers cut out into deep into the middle. We look at the way that the rocks are, the way they look, the way that what kinds of things are in the rocks because life was once there. So if we look at past places on Earth that had life that no longer carry the same kind of life, we can find patterns that we can use to judge if other planets had life. So we know that Earth, Mars, and other rocky planets can be thought of as systems. These systems are made up of interacting spheres that can include geosphere, atmosphere, hydrosphere, and biosphere. Now, it's likely that some of these planets will only have a few of these, but we're looking for mostly which one of them have biospheres, because the biospheres would tell us if there was life there. So for homework, you will record your ideas about the signs of past habitability on Mars. Then you'll read the article Scale in the Solar System. For classwork, right after you watch this video, I want you to write a CER and explain which of the planets you believe was the most habitable of the 4 planets that you studied: Mars, Mercury, Mars, and Venus. So you're going to choose one planet, decide which one was most habitable based off of the information you gathered from your classmates about the sphere that they studied and from the video. See you guys soon.